Hello, and sorry for the previous video being cut halfway through. iMovie is not allowing me to make a 1 hour, 10-minute video for whatever reason, so I had to split these into two sections, and here is part 2 of this video. Now let's look. It's saying first that the tokenizer was trained on data from earlier sites, so it has seen this data, which is to say that you take the training docs, right? And I think he just goes to the next parquet, which is the start of val. That's the understanding I get. Sorry guys, I'm kind of tweaking right now. Sure, yeah. So this is getting the val text. So we get all of the text here from above, which is like completely new. And then we also have the validation text. Yeah, I don't know why. Okay, let's see. Why did he actually use the train text? So is he using the train text to test the tokenizer? That doesn't really make sense. But okay, let's just ignore that for now. I don't know why we're testing on the training set, but we do have before seen data anyways. And then we will load the GPT-2, the GPT-4, and our tokenizer. So actually the results here, right? When we compare with GPT-2 and GPT-4, like these should be the same because those tokenizers aren't changing. We really want to just compare the Rust BP tokenizer with the NanoChat tokenizer. So let's come back here to token eval.py, and we might as well get that out of the way for now, so we don't need it. All right, we check the vocab sizes. Then for every text, we'll encode, decode it, and then we'll put the results. Pretty simple stuff. Add some color, print the vocab sizes, print the comparison, which is going to come in which one, the tokenizer.evaluation.md with the pipes in between them to separate the data. Print comparison, boom. It's just a bunch of printing. I don't think you guys are too interested in that, and I am not for sure. So let's just have that set up and out of the way. Token eval, and now we just need the SSH script. So if I come here and say, come out of this and just go to NanoChat, the shell is just called speedrun.sh, I think, right? And let's come into speedrun.sh and see what it says. So the script will essentially train a model not only for the tokenizer, but also for the model. So we want to get rid of that stuff and only train that which is necessary for the tokenizer. So you can see here that we're getting the base dir that is, we're calling it the home directory, the cache NanoChat, but let me just make sure that I'm certain that it will just choose the directory that is on cache anyways, right? If we don't have the thing initialized, it will just grab the cache NanoChat. So we don't even need to set that environment variable, right? Why isn't the shell script open? Oh my God, you just opened a new one. Okay, there you go. So we can remove all of this. We can remove the UV sync stuff and the source activate since I'm going to activate the venv right now. We also don't care about 1db. The first thing that we're going to set up is this. So the python m.report reset, because I already brought the data into the directory here. And if you guys just want to see what's currently in the cache for the NanoChat, it's just the data itself. So we have base data and eval bundle. So base data, what does that look like? It's a bunch of parquet files. And then eval data, what does that look like? It's eval bundle, eval data in CSV, OpenAI stuff. What is that? A bunch of CSVs for the different GPT-2 variants. So yeah, that won't be reset. The report will be reset, which means it'll just be initialized. So let's delete everything from there up onwards. We don't need anything to do with Rust, which is really nice. And then I've already downloaded all the data, so we can get rid of that. We essentially just need 3 lines of this script, which is to say, train the tokenizer with vocab size of this. That's just the default with 2 billion bytes, and then evaluate the tokenizer. Everything else is for the base model. So boom, let's get rid of that. And then let me just rename this speedrun.sh to tokenizer.sh. And then now we can open tokenizer.sh. And I'm literally pretty sure, right? We have some problems here. So what are those problems? Oh, I have RustBP tokenizer defined here. So let's see. No, I guess not. Let me just make sure it's not anywhere here. Okay, that's just in my practice code, so that's not there. I mean, I'm just gonna run it, and then if we get problems, then we'll troubleshoot them as we get them. So literally just do tokenizer.sh. Is it not runnable as a file? Why aren't you letting me run it? Is it gonna say that it doesn't have, okay, permission denied? So we're just gonna do a chmod. I think it's 7770 of all the permissions. And then now, boom, we're good. So yeah, we should kind of wait. In theory, stuff should be printed as it trains the tokenizer. Okay, reset report and wrote header to here. So if we just open this, then we'll see what is there. Okay, so we have issues, guys, which we will resolve. All right, so the tokenizer.pickle did not exist, so it should have created that when it trained it. So let's see what's going on. Let's go to the train and see where is it actually saved. Right, we have the baster, get baster. One thing I want to make sure is that the environment variable for the NanoChat tokenizer isn't, so not the NanoChat tokenizer, but for NanoChat baster isn't like something else. So I think we just need to go this, echo. Okay, it's not there. So it's not being saved somewhere else where it shouldn't be saved. Let me just look at the entire error. Okay, so you reset the report and row header to this. We had these parameters, which is all fine. And then, okay, now I'm trained from iterator. This is what it should be doing. And then now, missing one required position pattern. Okay, there we go. Now we see what the error is. So why is pattern not being, why is it not being imported, or not imported, but initialized? I think it's because it's hard coded in the actual implementation. So instead, right, we're gonna come back to tokenizer.py and then just give it like a default parameter. So I guess now we're just gonna get rid of the plan since there's nothing else left, and then hope that I have somewhere right, I do have it here. So I'm gonna grab this, and apparently the NanoChat tokenizer. So hold on. Do I need to add the pattern or I need to remove it? Let's see what it says again. Missing one required positional argument pattern. And this is in which file? It's in TOK train. So let's just make sure this is in line 49. I just want to look at this line to see what the context is. So line 49, yeah, we train it with text error and argslook size, but in our code, it expects a pattern. So I think our code is then wrong. So let's come to tokenizer.py and just say class NanoChat. Right, it expects a pattern here, and it doesn't expect the pattern in Karpathy's code. So let's just look at the code for Karpathy, because I want to see how he handles it so that we know what we're doing and that it is faithful to his implementation, because that's the entire objective of this series. So it should be in, whatever, let's grab it from here. It should be in NanoChat tokenizer, and let's put it in NanoChat, and let's just call it temp.py so it doesn't overwrite our current tokenizer. And let's go into RustBP, because that's essentially what the name is of the tokenizer that Karpathy uses. Okay, so yeah, there is no pattern used. So where does he get pattern from? Okay, do we have a get pattern method that we implemented? Because I didn't implement all methods. If they were kind of redundant, then okay. So we don't have that method. So let's actually see what that method looks like. So we can implement it right now. I think it's just like a simple getter method. Where's the temp? There you go. Temp. sorry, get tokenizer. Sorry, get pattern. I'm sorry, guys. Okay, get pattern. Why isn't it loading? We must be importing it from somewhere. Okay, so my mom started calling her niece and then had to wait for her to finish that call so it wasn't bothering the recording, and now we're good to go again. So we were looking at where the pattern is received. So tokenizer.getPattern, and we're in the temp.py, right? So I'm not sure why it's not appearing anywhere when I call this function. So let me come to, this is like the repository where all of the NanoChat code is, right? And it's in get pattern. Okay. You know why? It's because it's in the Rust implementation. Okay, I understand now. So now if we come back here, we just need to implement it in our code. Literally, it just returns the self.pattern.clone. So, right, tokenizer is a Rust.bp tokenizer, but in our case, it's a regex tokenizer, if I'm not mistaken. Right, it is. Okay, so in pattern here, we can check, does regex tokenizer accept a pattern as a default? First of all. Okay, it does? I don't understand. This pattern is not actually used, which is funny. So we can just delete it. Like, that pattern was never used, but what we do is we do need to just make a def get underscore pattern, which will take self and then return self.pattern. I am assuming it's returning the compiled pattern and not that just like the pattern in plain text. So now that that is there, we need to come back to the NanoChat tokenizer. We never needed pattern here, but where is pattern, right? Pattern also is going to leave this, and then we will just do tokenizer, right, dot get pattern. Sick. Okay. So unless something else is out of order, this may or may not work. So let's check. Okay, so something's wrong with our regex splitting. Let's come back up here. re.findAll, self.pattern. The pattern is the re-compile, the text. I mean, we can just print the text every time because for some reason the text is not being handled properly, right? So this will probably overflow our, okay, it's the generated iterator. It's because it's the text iterator. Hold on. How is this handled in the implementation that Carpatha uses? Okay, we have a text iterator, right? And it's been flattened. Let's actually look at how this is happening, right? We return the text iterator object here after we flatten it. If we just check the Rust implementation, this will probably give us the answer, even though we probably just have to index it by text. Okay, train from iterator. And okay, the iterator is what we want. Prepare a true Python iterator object. I don't know what that is. Okay, iterator is here. Get as pointer, processing sequences iterator. Hold on. Okay, that's it in terms of the iterator being called. So what does this return? It just returns. It doesn't return an object. I don't understand how this function works. Right, so what are the elements of this object? Because we literally just have a function return here. If we come back here, right, to the iterator. Hold on, let's come back to NanoChat, right? And how does it treat the text iterator? Tokenizer.train on the text. Okay, does Karpathy do this somehow differently? Oh no, we can just check temp, which is his implementation. Okay, we get the iterator, and then what do we do with it? Train from iterator. No, it's the exact same thing. So it is definitely in the librs in train from iterator. Let's look back at train underscore from iterator. Okay, we just have to look at comments because I can't read Rust code. Use provided pattern, update the stored pattern, compile it. So he's compiling in here, whereas we're compiling. Is it possible that we're compiling the regex twice? Right, that might be it. So if I just test something out here, which is to say dot pattern. No, that wouldn't affect it because the error is actually before. I think this is fine since we're handling the pattern compiling on our own. So we know we have like the entire life cycle over the pattern. We know that it's being compiled within the regex tokenizer and nowhere else. Yeah, I think, I mean, the problem literally is with the text. Am I not mistaken? Right? Expected string or buffer. I think it's saying expected a string or buffer as the regex. Sorry, as the training, but it's getting a generator object text iterator at this. Okay, so let's go back to his function and see what it's done. Prepare a true Python iterator object. Okay, I think this is the key here. Right, because I don't know what this function, okay, pyiter is what we want. Okay, yes, so pyiter is what he's creating from the iterator, and I don't know what any of that means, but it's somehow get iter on iterator as pointer is what he's calling. And this is done in our train from iterator. So, okay, where is the train again? Train? Is there like a get underscore iter? Okay, I don't think that's gonna work. Let me just, let's ask old Claude. Okay, so if I come and let me just momentarily make this smaller. Let's say, okay, let's understand the error. We have, I want to give tokenizer.train the text, but it receives currently and gets this error. And what error is it getting? My cursor is no longer working on Pro, so you're gonna have to just use my Claude API key, and we get, what do we get? Let's just see what it says. That is correct. Convert the generator string before parsing. So I think, is it literally just this simple? If text editor is a generator, text concatenate out chunks, or if it yields lines. Okay, I think it's a generator. So I think we can just do this. I really am at a loss of how generators work in Python. So yeah. Okay. Train from iterator, where's that called? Sorry, I don't want to do that. Let's get rid of that for now. Train from iterator. Shoot. You had it? Okay. Yeah, let's try this right now. Why not try? I'm gonna get. Actually, I won't get rid of the print for now, but it may overflow our chat. If it does, then it's okay because that will mean it at least was working. Hey, I think we would have errored out way sooner before, but I mean, it could just be that the error is propagating downwards. So let's get rid of that and fill this back up. I mean, I am pretty optimistic that it's training now, but I'm confused why it hasn't printed anything because where did we put that print? We are in tokenizer.py. It was in the train method. Right here. For some reason, it's no longer printing the text. But what is good is that, I mean, we're not getting any errors. So let's, in the meantime, I'm going to open back up this so we can clean up CD into NanoChat from scratch. And then let's remove the tokenize that we took from Karpathy. Boom. So let's go boom, boom. And everything else that we have, okay, is straight from what we made. So tokenize.py, that's still there. The eval, the train, the report, the header, and the pyproject.tom. Cool. So what's the status? It did take 48 seconds previously, so this one might also take the same amount of time, but I mean, it has been 48 seconds since. Okay, guys, so clearly the text is being printed, and what this means is that we're only in this stage of the training, which is strange. Of course, I just realized, yeah, the Python is gonna be much slower than Rust, so we shouldn't expect it to take 48 seconds, and it has been like a few minutes already. But, right, if it only just got here after a few minutes, then I'm not sure what it was doing beforehand, because before printing the text, there isn't much that we do, right? This is the main logic here, is the merge that we're doing. But, yeah, okay, it just stopped. Oh, I think I just did something stupid. Let's just get rid of that print so that in the future, there isn't weird overflow happening in the terminal. Okay. Even my computer's kind of lagging right now, so I hope this didn't like do any weird things for me here. So it turned out that it was doing some weird things for me, and the Python implementation just was doomed from the beginning. So if I show you guys what I've been running for a really long time, this is after optimizing the Python code, which is insane. Like essentially repeating or copying the Rust implementation and just porting it to Python. And we have only done 1,000 of these 65,000 merges. And this might look impressive, right? It's like 6% or whatever. But if I come here to the report and see what time it was at, this was done at 14:59. And even I actually started recording this video at like 9 a.m. because I was just trying quite a few different techniques to get this thing working. But I have a handy extension here that just prints the time. And yeah, it's currently 16:41, so 4:41. So it's been 1 hour and 40 minutes, so not that insane. And we've only got 1,000 merges. So the moral of the story here is that the amount of overhead in Python just does not allow to be competitive with Rust whatsoever. Like it's literally taking 60 seconds with Rust. And I just got Gemini 3 Pro to give me some analysis here. I just said like, okay, can you give me a high level and concise rundown because I have understood at this point that Rust takes 1 minute to do the tokenization over 65,000 plus merges, and Python can't do it in any amount of time for what I'm seeing on my computer. How is that so? It's that there's such a stark difference. So there are 4 reasons Python hangs and Rust finishes in a minute. First of all, we're going through the entire dictionary of words stopped at 65,000 pairs, but in Rust it tracks exactly where every pair is located because it's an array. I think it's contiguous. And then when it merges A plus B, it only touches the specific words that contain A plus B and it ignores everything else. Also, we have a heap. So to find the most frequent pair, we just have to do an ONN search. You can implement a heap in Python, but since it was saying that Python used linked lists instead of like arrays, that it's still like in the order of n in terms of the time complexity. But yeah, it's just a priority heap for popping the next pair, which has the highest occurrence. And like this is what I'm saying, pointer chasing versus contiguous memory. A list of integers is actually a list of pointers, but this is a solid block of memory. The CPU loads a chunk of it, processes it instantly, whatever SIMD is. And also there's the global interpreter lock in Python, which prevents multi-threaded running. Like you can't parallelize it, but you can in Rust. And then another thing is lazy evaluation. So it double checks that a certain condition is true, and then I think you just can skip the rest of the loop if it is the case. And then yeah, in summary, I suppose that we're talking O of n squared versus n log n, and then we're literally in the order of like 2 billion tokens, right? Which is 2 gigabytes and 65,000 merges. So a n squared versus n log n does make a difference. And what is important is saying, even if you have LinkedIn, list, max heap, everything, it still makes it 100 times slower, and it's more than 100 times slower. So we can actually calculate, right, how long this should take, because it's done 1,000, right? So if I just would like to come here into a Python shell so that I can just do Python 3. Python 3. I can't spell Python, guys. RIP. Okay, so we've done 1,000 of 65,000, right? So like, oh, is it really just 1%? Okay, so it's really like 1 or 2%, right? We don't need to do the calculation. So like, we're talking in the order of 100 hours. And that's not good. Let's just mention that straight off the bat. So now what we're gonna do instead is a consolation prize, which is to say that I'm gonna stop this loop here. And I'm gonna make sure that this still runs because I did change the code because that was the optimized code that you guys need to understand. Okay, so I did actually change this back, which sucks, but we have to fix this. So pattern is no longer needed here. It takes the pattern. Let me see if this just fixes it right off the bat or if I still need to do something else. Right, it doesn't have a train from iterator, that's true. Ah, geez, man. I think I should have grabbed this from a previous, like I essentially just restored a previous commit, but I think I went too far. Here, the text is there. So we'll just do text equals text dot, oh, sorry, not this. What did Claude tell us to do? Come on. Damn, how far is it? You can see that I went through a lot trying to get this thing to work. Right. Okay, it is just literally with the, I was unsure about what I should do as the delimiter, but it's just the empty string. Okay. Is this what I was saying? Let's close this so I can actually see everything. Right. NanoChatTokenizer has no attribute trained from iterator. Yes, now I changed the call to train from iterator. So let's see what happens now. Okay, so of course we're not going to do 2 billion, right? We don't have the capacity to do that in Python. So instead, we're just going to do, okay, max characters, I don't know, like 20,000. The vocab size is too large at 65,000, so I think we should also change that. And we just want to make sure that it at least works, right? So vocab size, let's do 1,000. And try to run this. So this is, once again, what we're doing in lieu of the, okay, what's going on? Vocab size, did I specify it wrong? I did. Oh, it's underscore. Oops. Okay, let's try that one more time. Okay. Right. It doesn't even have get pattern, guys. RIP. Okay, so I'm just gonna go like def get underscore pattern self returns self.get self.pattern. All right. Okay, cool. Cool. So, oh, that's fast. Okay, training time, 3.9 seconds. Look at that, guys. That's impressive. So we got all the merges here that I printed out, I guess, from the debugging. That's the merge table and the merges. So we have a tokenizer now, and we can actually look at the stats. So if we come here into tokenizer, into the tokenizer training MD, see what happens. Right, max characters, these are just what we specified. It took 3.9 seconds, 9 special tokens. The minimum token bytes is 1, which just makes sense, like just A, B, C, those would be the tokens would have bytes 1. Max is 15, the mean tokens per bytes is 3.5, and the standard deviation is 1.957. Actually, what does it look like for the Regix tokenizer? Sorry, the Rust tokenizer. Right, 32, so you trade it for much longer. And you have a larger token bytes mean, just says you have more merges, and a bigger standard deviation, so there's more tokens, and it only took 48 seconds. Actually, I'll show you guys the run, what it looks like with Rust, right? Do not full screen me, please. Okay, so what did I do in Rust, right? I came here, I just did in the NanoChat repo Python m NanoChat report reset, and do a script on 2 billion characters. And look at this. Okay, so what does it do? First, it processes sequences from iterator. So it has literally an iterator of buffer 8192, and it's like segmenting the vocab over the, I don't know if it's segmenting over the the vocab size of 65,000 or the data set size. Actually, I think it's, the data set size, so sequences, right? We're splitting up the data set of 2 billion tokens into buffers of 8,192 and then processing them in parallel in batches, to my understanding. So we processed 532,496. So like when we do the regex split, this is how many sequences we get. And we also keep the number of unique ones in context, right? This is what, 2,233,873. And you might be asking, why is this more than the number of sequences? This is because this is on like the token level, like the number of words, but then this is just on the regex split level. So like you could have a regex split with like a whole sentence, right? From what I understand, like if you have like just a sentence with no punctuation or anything, as soon as you run the RE split, or not as soon as, but when you do this dot find all, I don't know actually where he has it. I think it's somewhere here. Find all, RE dot find. Okay, it's probably in the Rust implementation. And because of that, I don't know what to search for because I don't know how to do regex in Rust. But all this is to say is that this is the number of sequences that the regex split found, and this is the number of unique sequences. So like hello is one unique token or word. In fact, I just learned that, you might have known this, but it seems that Rust has a like word structure which represents strings, I guess, but that's my best guess. And that's what we're talking about when we're talking about like these unique sequences. So it should actually be unique words. And then we build a heap with the unique pairs, and then you start the merge loop. So you can see we're talking in the order of seconds here that it's doing this. It's actually insanely fast. Why don't I just run this one more time? It will erase the data that we just generated for our tokenizer. But okay, we'll say that for now. But yeah, I just wanted to give you guys a look. 68 seconds, interestingly enough, it was 20 seconds slower because I think I had so many things running simultaneously on my computer that it had to attribute less resources to the run. But yeah, you can see we can get this working on a toy example with Python, and the pairs are merging, and we also have the compression happening. So we have successfully built a BP tokenizer from scratch in Python. That's the goal, and we are successful in that. If you look at the compression ratio, right? I think like the initial compression would just be 1, right? And actually, I forget how did we calculate compression? I totally forget. Did we still have, yeah. Oh, it's the, okay, length initial over length final. What is length initial? What is length final? Yes, so if we have a text, right, and we tokenize it, then we'll get a compressed text. So if we just look at our header file here, I'm not sure if, I don't think we can get this simply on this basis. We'll have to now do token eval, which I totally forgot about. Okay, I actually didn't try this. So we can try this together and see whether or not it will give us the, not the correct answer, but if it will actually run. So let's just go here. I totally forgot about this. Okay, since we have saved the tokenizer there, it should work in theory. Ooh, okay, it does. Holy crap. Okay, guys, this is cool. So yeah, ours literally has a vocab as a 1000, right? And you can see everything is red. Okay, now we can see the compression ratios, right? So GPT-2 compressed this by 4.5, GPT-4 by 4.7, right? And ours is abysmal, right? I mean, it's still compressing, but like, especially for math, right? Since it doesn't know anything about math, since the training text must not have been math, it doesn't know anything. In Korean, we have 3% better compression than just using the byte sequences themselves, raw. So look at these relative differences, even though actually the relative difference here is not bad, because I guess GPT-2 is really bad at Korean, but then in GPT-4, they really improved with Korean. So there you go. And then if we come and look at what the differences are for the Rust BP tokenizer, right? This is slightly less well formatted, I would say, right? We have GPT. All we need to know is that the percentages are here, right? So in most cases, the tokenizer is actually better than the GPT-2 tokenizer. You can see the only thing that GPT-2 is better than the Rust BP one is in math. And then of course, GPT-4 has a better tokenizer, except for news, which is interesting, and science. And actually of course, on the training and eval, it makes sense that the tokenizer retrain is slightly better, but yeah, math, code, of course, GPT-4 is better at tokenizing, but otherwise it's respectable for like just the news and like English stuff, apart from Korean. So you can definitely be sure that GPT-4 has a lot of language specific stuff, like maybe like literally for every language, there's a special tokenization regime which respects better the grammar. Like, I don't know, in Mandarin you have, I don't know if you have spaces, I don't know if you have sentences, but there you go. And there you have it. So as you guys can see, I'm not going to run the Rust BP tokenizer. Like you guys can see, it takes 65 seconds to do. Very impressive. If you're really into learning Rust or no Rust, then it's pretty tractable, right? 400 lines of code to understand the exact same implementation we did Python and Rust. And if you did follow through the series, then you would have the necessary background information to understand that much faster than you would if it was just raw. But yeah, we've actually gone through everything based on the tokenizer. I'm very excited about this. So I hope you enjoyed this video, and I'll catch you in the next one.